Hey everyone, so really cool video for you today for the hydro fans. So we're going over to a farm there's a young farmer, works farm, inherited farm, and he wanted to get a hydroelectric system set up a while ago. He had it set up initially himself, just like cobbled together with some stuff laying around the farm, and initially he got it set up with like cheap Pelton spoons and things you get off eBay, and like had a belt drive system on it, and he had it connected to a synchronous motor that you get off like an old petrol generator, all made from stuff that's just laying around the farm, old bits of pipe and lay flat pipe for slurry and stuff like that. And he got a turbine set up and he had it going at about 300 watts. And he contacted me via my website to ask if I could offer some help and assistance on like a more efficient or better motor to use. And so we did. We ran through everything he had laying around the farm, and he had a old solar charge controller, a Solace one, which are actually really good, from an old solar system that was on a barn that had a fire, and they managed to save it. And so he had that, and he had some induction motors lying around as well. And so we went through everything he had and started getting him set up. The goal was never to make the absolute best thing. It was to make something that was as best as he could make from the stuff he had laying around the farm, you know, for very cheap, which, you know, is something that appeals to me a lot, which is why I was really interested in it. And he's a very clever guy, very practically minded guy, able to do all the stuff himself. Just wanted a bit of advice from the experience I'd learned from going through this same process of learning as I go along. And so yeah, we found out what he had around, and he ended up having a few induction motors, and we got stuff set up with like belt drive and stuff, because the induction motor wasn't the right induction motor, but we managed to make some things work with some belts and pulleys and things. And over the course of that time, just using stuff that was laying around, we managed to get him up to about 1300 watts, and that was obviously making a big dent in their electric bill, which at the time was about £6,000 a year. And so that was really good, but he decided he wanted some more out of it, and so we got it connected direct drive to a 2.2 kilowatt motor, which was a 4-pole motor, which still wasn't the right thing, but it was something he was managed to get for cheap, or took off something else. It was almost free anyway. It was more suited than the one he currently had, and he managed to get it up to direct driven on this one, doing 2.1 kilowatts with some slightly bigger nozzles and so on, but we're up to 2.1 kilowatts, but it was spinning way too quick because it wasn't the right motor. And it was making the cow shed that it's attached to like vibrate and stuff, and it wasn't quite right. But 2.1 kilowatts is really good, and so it stayed like that for quite a while. Basically offset all of their electric bill, no more electric bill, but he wanted it to be right, get a bit more power out of it, slow it down a bit, stop it from shaking the shed and so on. And so he decided to actually spend a bit of money on it and actually look to buy the correct motor. So I worked it all out from the turbine size and stuff that we had. He'd now changed the turbine to be a much sturdier turbine with some spoons that were my recommendation. And we worked out that the type of motor needed would be a 4 kilowatt induction motor, 6-pole, because that gave the right speed. It's about 1000 RPM with his nozzle velocities. And so yeah, that's what we're doing. That's what we're going today, heading off to go and get that fitted and try and get the system up to pretty good standard, really. Just all it needs is this motor, and I'll show you around the system how it works. It's really cool. Almost entirely, other than this motor and a bit of some of the pipe, is stuff that was just laying around the farm. And it's yeah, really cool, really nice intake, really high potential site, just really cool, and yeah, really nice guy as well. So yeah, so we'll go over there and we'll play around in some streams and mess around with some hydroelectric. Right, so yeah, this is the setup, the farmer built setup I was telling you about. So I'll show you what's going on here and what we're changing. Excuse the cow noises, we're in a cow shed. So when I first advised the farmer to set this up, he had this induction motor here laying around, and as a result he used it, but it wasn't big enough and it's got too fewer poles, so it spins too fast. So it's taken a while to get hold of, but we've got this, which is the correct size now. This is a 4 kilowatt 6-pole motor, so this will spin at the correct speed, because when he was running off of this one, because it was spinning too quickly, it was allowing some of the water to pass through without transferring its energy over. And so now we're onto this bigger one. This can take more torque and spin at a slower speed, and it's more matched to the size of the Pelton wheel, which I'll show you in a minute. So this is now the correct motor. That one though was sort of just laying around and free, so we used it for a bit. That one cost quite a few £100. So here is the Pelton wheel itself. So it's 2 nozzles. It's a flow rate of about 8 litres per second. This is about the 4th version of it. So the first version was just a piece of metal with some really crap Pelton spoons on it. This one is now much higher quality than nylon spoons I advise the customer to get. And he's got it nice and concentric on this nice little locking bush. And like I say, 2 nozzles, and then it's controlled down here. There's a valve block, and then that, obviously there's the pipe coming in, and that goes all the way up the hill. I think it's 60 metres head if my memory serves. So yeah, that's what we're dealing with. So today's job is to get this new motor hooked up, get the capacitance right, and try and get this working much better, because what was happening before is this jet of water, because this is spinning too quickly, it was moving out of the way quicker than the jet of water, and so a lot of water was hitting the back there. So we get this old motor disconnected, this is the lead, get that connected up to the new bigger motor, and then in there, I'll show you in a minute, we've got capacitors, and we'll get the capacitors hooked up, and then we'll do some testing. So this motor is currently wired in star. I hope you can see that. So see this plate going across here, these actually need to bridge across this way, because at the moment it's wired for 400 volts, we want it wired for 240, 230, so just change that. Right, there we go, it's all wired up, so it goes in delta, so we've got them joined together. Now 3 terminals coming off of there. I'm just changing these capacitors like for like. The old ones, because the motor was smaller, is a 60s, so 60 microfarads, and because it's a bigger motor, sorry about the cow, it's a bigger motor, should be around 80, but we'll do a bit of experimentation once we've got it up and running. So what is going on here is that the turbine is coming into here, these 3 phases here, 1, 2, 3, and you can see the capacitors are also coming off of those. And the capacitors, because the motor is a 3-phase motor, but it's not connected to a 3-phase supply, these capacitors are taking a tiny little bit of voltage from the inside of the motor, building a current inside these, or a voltage and a current inside these capacitors, and then these feed back into it and induce the magnetism inside the induction motor, and without these it won't work as a generator. And so that's what's happening. You see these are linked together, so they loop over each other and they're wired up in delta. So I'll just change that last one. Once we've got this all working properly, I'm sure the customer will tidy all this up and mount them and stuff, but for now, for experimentation, we'll just rest them there like that, because we're going to be checking some voltages and stuff. Right, so he's just putting a little bit of water on just to make sure everything's lined up properly, just to see if it's at the centre of the jet. A little bit more. That'll probably just about do to see what's going on.
Yeah, I can block one and then oh, actually it doesn't look too bad.
Yeah, it actually looks quite good. Right, so we're just trying to get the alignment correct. So at the moment, this isn't quite right. This jet is a little bit too low, yeah. And so you can see we've got this water getting lost out the back here. Yeah. You see this is lost flow, and that's what's caused this to erode away a bit down here. Yeah. So we want to try and bring that jet up a bit, and so that water's not lost out the back. See that? Yeah, so we're just doing a few little modifications. As you see, we've taken everything out. So the motor's out, turbine's off, because it just looked to me like the nozzle orientation wasn't quite right. So we're just taking it apart and we're just going to adjust the nozzles and then see if that helps out. So yeah, what was happening was the top nozzle was facing a little bit too low in the spoon, and the bottom nozzle was a little bit low in the spoon. So we're going to bring both nozzles up a bit. That'll make that one slightly better and that one slightly better. That's it. There we go. You can see we've got the jets quite good now. See how they're sitting pretty good. They're blasting out the back because it's not loaded yet. Yeah, it's looking better. This is where the water from the intake dam comes into. Just comes into an IBC tank, and then from there it goes all the way down the hill, down that pipe, 60 something meters of head. And so this is like a settling, gets the air out, settling tank. So really nice design really, but at the moment it's mostly empty, so we need to go and improve the flow a little bit. So there's plenty of water coming into this first. This is basically just a way of joining pipes together and like clean out. So from here it then goes off down into that IBC tank. And so we've got plenty of water here, but it's not quite filling the IBC at the moment. Yeah, that's about the flow rate. So we are up at the intake dam. So this is the first stage of the dam, which catches the water from the stream above. Then that water goes down that pipe there. The water then flows along here through this cheap piece of pipe, which is just laying around. And then we go over to here where we have this really nice intake screen. The water flows around here and then into one of these spinning intakes, which are fantastic. They're not always feasible to do because you need a lot of space, and you don't always have this much space and the ability to lose head and come out sideways. But in this situation, that is so nice because it's obviously self-cleaning, continuously cleans itself, very reliable. But from this point here, the water then goes down the hill to that IBC tank, and then once it gets to the IBC tank, it then shoots off down the pipe, and then it's pressure pipe then, and then that becomes the actual water that's used in the turbine as such, pressurized. From here it's not pressurized, it's just flowing in an open pipe all the way. You know, there's no pressure to it, it's just flowing downhill. Once it gets down to that IBC container, there's no air in it and it's pressurized, then it goes downhill sharply to the turbine. Really nice, reliable setup. Give this a try. You should hear that latch in a second. There we go, she's latched. Alright, so it should just about latch. There it goes, latching. See the power building up. $2,500 So we were at 2.1 and now we're seeing 2.5, just over 2.5. It's not a bad increase. I was hoping for a little bit more than that. I think there are still some small improvements to make, but 2.1 to 2.5. But the main thing is it's much quieter. It was spinning way too fast. It was shaking the building and the shed. Now it sounds much more reasonable. Yeah, would hope to see a little bit more, but I think there might be a bit of air in it. We might see 2.6 yet. We'll see. Let us settle in for a minute. Right, so it's working quite well. I'm happy with it. It's just that I was expecting a bit more power, so I just want to make sure that we know what the flow rate is, because I was expecting about 3 kilowatts and we're only getting 2.5, so well, just over 2.5, so we're missing a bit of power. So I'm going to go and measure the flow rate. What we're going to do is we're going to go up to the top, we're going to disconnect the water going into the IBC tank, stopwatch to see how long it takes to drain the IBC tank. That'll tell us what the flow rate is, then we can work out exactly what we should be getting. So yeah, we just come up to the IBC and see it's empty. Can you see the level there? So that's why we're not quite getting the amount. So I want to know what the flow rate is anyway, so we're still going to carry on with the test, but that's why we're not getting what we expect at the minute. The flow rate's just a little bit too low. Right, so we're just timing the flow rate. See the IBC's filling up there. So once it gets to the top, we'll stop it, and that'll give us an idea of the flow rate. We're also going to do it back down in the other direction, and we can see what the flow rate is then. Right, so we are now overflowing, and it took 1 minute 55 to fill 1,000 litres. So that's our first recording. And back up at the dam, we're just trying to get a little bit more flow, just so we can do a proper test. But it's just my luck. It just so happens that it's a little bit dry at the moment, not quite getting a full flow rate. The intake is it's just draining, which means we can't run it for any length of time, which tells us much about what our output is. See, it's not quite overflowing, that just wants a little bit more water. So the owner of the land has just diverted some of the water away from this channel, which goes down into the natural stream, and sent a little bit more down this channel, which you can see is kind of a man-made channel, and then a little bit more into the dam, and then we'll get a little bit more flow down to the intake. Right, one last look at this, because that's it for today coming up here. So yeah, very, very cool, very reliable intake. If you've got space like this, perfect design. So there we go, 2,500. That's about the best we can get it at the moment. It's raining now. I think that'll pick up a bit once you get a bit more flow rate, but it's just dropping the IBC, and so it's just dropping off. But this morning it was at 2,100 and really loud and noisy and shaking the shed, and now it's at 2,500. So yeah, I think this is mostly a success. We've improved the power and it's running much quieter now. That's the key thing. And before, the water was blasting right out the bottom of there. It was running very inefficient. Needs a bit of a bolt there. Yeah. So yeah, that is the entirety of the hydroelectric system. An induction motor with a Pelton wheel coupled to the other side of it, sticking out the side of the cow shed. An old enclosure that was lying around on the farm with a few capacitors in it. 200 metres of 90mm MDPE pipe to an IBC tank. And from the IBC tank, some old drainage pipe that was laying around on the farm to a small dam made out of stone, and an intake made out of scrap, and 2.5 kilowatts. Really, really good. 2.5 kilowatts, 24 hours a day, 365 days a year. Hey everyone, back home. It's a lovely evening, and seeing as it's a hydro video, thought I'd come up and sit next to our own hydroelectric intake. It rained quite a bit yesterday. As you can see at the end of that video, it started raining a lot, and it rained here as well, so we've got quite a bit of flow. It's not actually on at the moment because we've got so much solar, we just don't need it, so it's off. Yeah, system's all good, ran all winter as always. yeah, I do still plan to do the upgrade at the back of the woodland on the other stream and tie the two systems together into one turbine. Might try and get around to that in the winter, we'll see. I'd like to. Yeah, pretty successful trip over at the farm. Really like the system. It's got such high potential. It could really in the winter go to like 7 kilowatts or so, or maybe even 10. But the problem is the customer only ran pipe that he had, and it's not really big enough, and so the flow rate that it's at currently is the maximum you can do, where you can run about 2 litres a second more. But after that, adding any more flow actually reduces the power because the pipe friction gets so high. And so it's kind of pushing the limits of what can be done with the pipe size at the moment. I think there are a few more tweaks, and I think if everything was really perfect and really like got every last little thing lined out and a tiny bit more flow, I think he'd probably just about push 3 kilowatts, but that'd be really hard to do. But I think we're going to try and do that, so stay tuned for that. So yeah, that's basically going to conclude this video. I just wanted to ask one thing to anyone out there in the know, and that is we did actually source another motor for it. He found one locally in a shop. It wasn't the right one, it was too high voltage, but we tried it anyway, and it wouldn't work. It wouldn't work as a generator. No matter what we did, we tried all the capacitors, it just would not work as a generator. It would try and latch and then it would just drop out. When we took it back out, we noticed it had a sticker on the side of it that said for VFD use only. So it's designed to only be used with a VFD drive. But I can't find any information online as to why that would make it any different, because I thought they would still be made the same, because you can take a normal motor, use it as generator and use it in a VFD, but this one said VFD drives only on it, and it wouldn't work as a generator. So if anyone out there in the know knows why that would be, I'd love to know, because I can't find any information about it online. Yeah, that's going to conclude this video. Really successful, 2.5 kilowatts, 365 days a year. A total of, what's that, 22 megawatt hours in a year, or 22,000 kilowatt hours. I think that's right, somewhere around then. So yeah, huge amount of energy, about 5-6 grand's worth of electric, depending on the cost. Cost at the moment's a bit lower than it was. Yeah, insane amount of power, and all from scraps. All right, hope you enjoyed the video, and thanks for watching.